You just have one quick question. What's the typical waiting time to replace an inverter from assigning a ticket to the arrival of a new inverter? It's very difficult to say. Unfortunately, when it comes to storage and things like that, there's so much more complexities. So sometimes it does take a little bit more time to exactly see what the problem is. If a device has totally failed, it's something completely different. That does happen once in a while. Then normally your replacement will be quite quick. But if it's just a strange occurrence or something strange happening, it can take a little bit of time to see that whether it's actually a device fault or a battery fault or a module fault. So it's very difficult to say exactly how long it takes. Normally, once the RMA is approved, it's normally within 1 or 2 business days the shipping of a new replacement device. So next we move into troubleshooting. So troubleshooting, as I just said, with hybrids is unfortunately a lot more complex. So most of the problems can be analyzed from these 6 different perspectives. The preview modules, your batteries, the utility, the meter and CT, the monitoring, or the inverter itself. So when my customer reports a fault, where do we begin? So just to show a brief overview of tools that could be required for diagnosis. Remote diagnosis with SEMS portal, where and what to look for. On-site inspection as well, inverter LED inspection, and PV master alarms. This is a brief basic view of the tools. Installation resistance tester is most often used if there is a DC string fault and is a good piece of equipment to have when you are installing PV. DC power supply with the hybrids, not really needed so much. And then your general tools, multimeter, sprinkler tools, and such. So troubleshooting, these first steps, we're going to do a live demo here. So first is going to be the SEMS portal. So when a customer reports there's a problem, one of the first things we can do is come to the SEMS portal. So in SEMS portal, we have a lot of places where we can go to view problems that we're experiencing. I hope you can see my web browser quite nicely now. This is the typical plant on SEMS portal. So as you see, we've got alarms and reports that we can use to look for faults, as well as in the general plant overview. So in the general plant overview, we actually have a lot of information available to us. Here we can see the flow diagram, and on the side we can go into devices. Once you go into devices, here we can see all the relevant information from our inverter, all the different information, so the grid output power, the backup output power, the charge current limits from our BMS, the firmware version, state of health of our batteries, all the DC voltages and inputs. But next we have the curve. So the curve is something that I use quite a lot when we're looking for problems. So it's one of the first places you should come to have a look to see the problems. So here in the curve, we've got a drop-down list. So in the drop-down list, you'll see power, which is the same power graph as above. You can see the individual information from the MPPTs, the voltages, the currents, the voltage of the utility, the currents of the utility, like IAC. IAC is the output to the utility terminal of the inverter, so how much current it's outputting to the utility side of the inverter. So yeah, it's a lot of information for us. So especially when we're installing, we want to see that our power meter and everything's installed correctly. So when we have issues with the smart meters or wiring of the smart meters, especially on the 3-phase, I use this quite frequently, the power meter. On the 3-phase devices in this drop-down list, you'll find Way at the bottom, you'll find phase 1, phase 2, phase 3 of the smart meter. I'll show you an example of how and where I've seen problems like this in the past. So yeah, our smart meter, we can see nicely all the different that we can see. It's all consumption from the utility. There's no export. This plant does not allow export to the utility. So should this all have been flipped and we see during the night, we just see export, then we know there's a problem with the smart meter. So yeah, we can get a lot of information. Same with P backup. So P backup is the backup output power. So if we do have backup tripping off on the device or any problems like that, yeah, we can come and see what loads are running on the backup. Please also note, I'll also show this in an example, that the frequency here is 1 minute intervals shown in a 5-minute graph. So you can't always see exact spikes, especially with inductive loads, things like that, but I'll show that in the later explanation. Zoom. Zoom bar is not playing well with me at the moment. Under our alarms, so here in alarms, you'll see all the reported alarms from the devices. You'll see there's 2 status: happening, recovered, or all. Here you can also search by the plant serial number or plant name to see what alarms you've had in that plant specifically. You'll see under details. So under details, we give more detailed information of the fault. So this is the fault, this is the possible reasons for your fault, and the possible troubleshooting to resolve the fault. So should you be on site and you see there is an alarm, you can see there's an alarm in Settings Portal. This also does give you that first troubleshooting to see how to resolve the issue. Next, you can use the reports function. So in the reports, you can export the data. Yeah, it's quite simple. You simply select your plant, select your device, and then you can select the indicators. So this will go shortly. You can select the indicators. You can select all of them and export all the data to an Excel spreadsheet, or alternatively, you can create a curve. In the curve, you can select 2 integers, so 2 units, so essentially voltage and current. You can't select too many different voltages and currents, but you can select all your MPPT voltages, all your MPPT currents, and that's 2. You should be able to select your utility voltage as well, and currents. So this should generate us correct data. It's always selected with voltages and currents. That gives us 2 data points. So sometimes it does take a little bit of time to load. Sometimes if you select the wrong ones together, so normally you just do the voltage of your MPPTs on their own, and the current of your MPPTs to match that voltage and current. So sometimes, even though it's voltage and current, because we have a different, probably this UAC, which is causing a problem on that. But yeah, you can find a lot of information about the plants. One of the other places where you can have a look to see if there's any problems is on the Settings Portal app. So very often some of the fault finding that we'll go through now is pertaining to verifying the settings on the device. So the Settings Portal app does allow configuration of devices remotely. So especially if you have your installer account. If you don't have one and they're creating one with the GoodWe Plus, then you'll have access to this. So simply clicking on the plant on the Settings Portal app. Yeah, you'll scroll down to the bottom, you see your device. You simply select the device. That opens up. It will show us all that individual information of the device, but we have the blue configure button. So once we click on this, taking a little bit of time to load on this device. You'll read through the terms and conditions and make sure you agree to all the terms and conditions. And your app will open up the settings. So the hybrid inverters do have quite a lot of settings that you can configure from here. Please note this app is not designed to commission the system. It's only to change settings later on should you require should something change on site and the customer needs to use different work modes or things like that. We're expecting a power outage and you want to make sure the batteries are full. All these kind of different scenarios that one has, this is what it's designed to be used for. Even under the battery side, you can change the on-grid and off-grid depth of discharges on the devices. You can see, so if there's a battery problem, you can come and see and make sure the correct batteries are selected. The operating work mode, which the device is set in, is in general mode, is it backup mode, is it economic mode, as well as the export power limit as well that one could set. And then a few advanced functions that one can enable or disable. Like I said, this is generally only used for changing things later on. If the customer requires any change of work mode or anything like that, especially if you don't want to give them access to PV Master themselves, you can just log in here and change that for the customers. So yeah, just in the presentation, some examples. So when you send you the presentation, you'll see the examples of what we ran through to remind yourself. Then next we have the on-site troubleshooting. What I always recommend, please contact our support before you guys go onto site so we can try and resolve the issues as quickly as possible. As we know, you guys are busy. Very often you experience a problem. You're busy with installations. You can only get to your customer in the next day or two. Just create that support ticket. Get ahead of the game. Create that support ticket. Look online to see if you can see any problems. If you can't see any problems from your side, create a support ticket, let our team assist you and look into it to see exactly what the fault is. But there are sometimes things that you will have to do on site or can even ask the user of the device just to record on site, such as the LEDs, to submit with that support ticket. So the LEDs of the device generally tell us a lot of what's going on. I won't go through everything individually, as each different device and different model has different meanings for the LED indicators. You'll always find a table like this on the side of the inverter. So when you're on site and you're looking at the LEDs, you can just look at the side of the inverter. There you will find the breakdown, but you also find it in the user manual if it's slightly out of view for you to view. And like I say, sometimes strange things will be happening on site or our Wi-Fi is disconnected. It always helps if the user phones you, just ask them quickly do a recording of the front of the inverter just so we can see the LEDs, which will help us find the solution to resolve the problem. So next we go on site to, it could be you experience a problem, you're on site already or you're nearby the site. So now we head straight to site to go and see exactly what's happening with the customer. You'll open PV Master, connect to the device, and from PV Master we'll get all the information you need. So in the front page, you'll see the running work mode, the status of the meter communication, and the battery communication. So also the running work mode, normal, wait, or fault. So normal means it's in normal operation. Wait mode, it is waiting for something. So if there's no PV, no batteries, the device may remain in wait mode because it's waiting for a source of power. And fault mode, obviously, if it's experiencing a fault. If you go to the parameters at the bottom, and then you go to the alarms tab, so parameters, alarms. Now you'll see the last 100 recorded alarms on your device. So our devices record all the alarms that happen and save the last 100. So yeah, you'll get a lot of information. What's the fault description? So as you'll see, yeah, in this one fault description, it has 3 different faults. So utility loss, VAC failure, and FAC failure. Essentially, the utility is off. This, there's no voltage. This, there's no frequency. Then there's operating mode. Is it in wait mode? Is it in normal mode? Or is it in fault mode? So utility loss, it's a hybrid inverter. We have batteries, we have solar. Sometimes we might see wait mode, it's in the middle of the night. The batteries are flat, there's no PV anymore, the grid is off, so now the device is idle and sitting in wait mode. Then the type of message, is it an error message? Is it a warning message? So we do have warnings as well as errors. So error messages means there is a fault and the device reacted to that fault. A warning message is warning, there could be a fault coming. And then there is the date and time of the error. So if you've been to site before you've sort of created your support ticket, you've looked at the screen, you found errors, take screenshots, send it to us. That just helps our team to immediately see what the fault is and immediately know what to provide you for diagnosis or how to resolve the problem. Next, there's diagnose message. This sometimes gets confused with alarms because the alarms is under parameters alarms. Customers very often come to diagnose message, create a support ticket. My inverter is having so many alarms, please help me. Diagnose message is not alarms, it's logic messages. So yeah, the inverter is just saying, I am doing this because of this. So if the batteries are full, it's not allowed to charge anymore, it will say it cannot charge the batteries. Sometimes the messages aren't very clear, but it's generally just running information and the reasoning why the inverter is doing something. So it's very seldom used, so it's nothing we need to worry about. Next, we'll go through the common errors that we experience on the hybrids. So the most common error that we'll get is backup output shut down. The backup output can shut down for multiple different reasons, especially because we are limited to the inverter capacity on the backup. We need to confirm the peak load demand on the backup output to see whether there's been any problems. View the maximum discharge current of our batteries. Very often the battery discharge current it certainly does affect the maximum load you can run when you only have batteries available. The inverter won't take more from the batteries than what the BMS reports to it. An example of this is here below, where we can see only a 74 amp discharge. So on low voltage, you can see it's 48 volt nominal system. 74 amps is only about 3.6 kilowatts. So although you may have a 4 kilowatt or 5 kilowatt inverter, when there's only batteries available, we will only be able to discharge that 3.6 kilowatts. It's very important to make sure that our batteries are communicating well. If we have more batteries that are able to give more than this, then it could be that there's a BMS issue and it's only reporting that much. Very often we have to check what type of loads are running on the backup output. So inductive loads are unfortunately a problem, especially when there are cheaper inductive loads. Very cheap motors and pumps and things like that often have horrible power factors and just consume way too much power when they start up. That might require a soft starter to help mitigate the inrush currents, especially if you do require to use it under backup. And then we always need to make sure there are batteries connected to the device if we are using the backup output of the inverter. If there aren't any batteries and we just have solar, the backup might stay on, but as soon as there's a load change, the backup shuts off. Another example you'll see here in the alarms page, you've got internal fan failure. Please note this does not mean that there's a fail internal the device that failed. This is actually backup overload. 4096 is the code for backup overload. Our devices don't have internal fans on most of our models, so we don't actually have a flag for that. It's an old historic name that they've used, which needs to be changed, but it's backup overload. That's what this error code means. So like I said, that curve, here's the example that I was talking about earlier. This device is an ES 4.6. So the ES 4.6 can overload for a certain period of time. On the top, we've got an example. When the grid is available, this device was overloading above 4.6 kilowatt for quite some time before it shut down. So here we can quite clearly see what load caused the device to shut down. And then in the second one, when the grid's unavailable, we are limited to our battery discharge current. So the inverter will not over discharge those batteries. So if you have a limited battery discharge, you see we can't run it for too long on that, then you can't see the load that caused it to shut down. So if you do have any shutdowns like this and you are wondering exactly what it is, you can just contact support and they will see a recovery error from these devices to see exactly the reason for it to shut down. Please note with a shutdown like this, if you are experiencing it, please don't manually restart the inverter and switch it back on. That is very often the customer's natural reaction is switch everything completely off and switch it back on again. If you do that, then you clear the recovery error, so you can't see the reason why it shut down. Next on our three-phase devices is phase order fault. Always when you install a new ET, you connect the grid and everything up to the device, and then it's stuck in fault mode. The alarms, you can see phase order fault. So that just normally means that our phases aren't in the correct rotation on the device. Normally you just swap L2 and L3 on the AC terminals under the inverter or on your main breaker, and then that will resolve the phase order fault. So switch everything off, switch the cables around, switch it back on again, and that fault should be cleared. But this does create a secondary problem with our smart meters. Normally you would install the inverter, the smart meter, everything the same. Now we have phase order fault. We rectify this by the inverter, but we've not rectified it on the smart meter, and that can lead to other problems. We need to make sure if we rectify this fault on the inverter, we need to swap it on the smart meter too, to make sure that the same phases on the inverter are the same phases on the smart meter voltage sense. Next is our meter installation. That's why phase order fault is before this. Very often, I'll show the next example, exactly happened because of that. So this is a single phase device. You'll see export at night, no battery discharge, figures that don't make sense. That normally indicates a smart meter is installed incorrectly. So yeah, we have this device, which is a good example. It's set to 0 export. Unbalanced output is enabled on this device to maximize the savings. But this customer, we can clearly see the device still has significant export. So what happened, this customer had a phase order fault. They fixed the phase order fault, but they didn't fix it on the smart meter. So the first thing I did, I went to the meter phase. At the bottom, meter phase 2. I saw, okay, these are our export. You can't see export in phase 1. Can't see export in phase 3. The meter's reading phase 2 export. The IAC, I went into IAC. IAC2, inverter is practically not producing anything on IAC2. But on IAC3, you can see a similar pattern of the export. So the inverter is producing it on IAC3, but it's exporting on IAC2. So this is a clear indication the customer swapped the phases on the inverter, not on the smart meter, And that resulted then in constant export. So then how do we look to make sure our smart meter is always installed correctly? The meter placement is very important. The heaters measure the electric flow to and from the utility. So it's very important to place the CTs on this area over here between the main utility meter and the loads. It shouldn't be between the inverter and the loads. It should be between all the sources. So that's normally installed on your main incomer from the utility. Not there, not there, not there. We need to install it here. Next is our CTs. On our CTs we have an arrow. I have never ever had this be incorrect on any one of our CTs. So please always try and ensure to install the house to grid, the arrow in the correct direction towards the utility. Because if we know our CTs are correct, we'll see the direction from the arrow is correct, then we need to fault find in a different area to make sure where our problem is. Same with three phase, A, B, C, we always have that K to L. So K is the house, L is the grid. So L always points towards the grid. L is not the load. K to L. The next, which is very important, so very often our smart meter is not going to be installed in the customer's main distribution board because it's already full. So we have to install a subboard. We put the smart meter next door. We can't run the CTs through trunking, through cable trays. We undo that on the top of on the top of the smart meter. We route our cables nicely and we wire it back. Please pay careful attention to this wiring. This does happen sometimes. We do miss because A is here. A starts from right to left. So A, B, C. So A meaning L1, B, L2, C, L3. So very often logic would dictate that L1 would be here and L3 would be here. So please pay careful attention to this to make sure that they are correct. So that 1, 2, 3. CTA is on 7 and 8, CTB 5 and 6, and CT3 3 and 4. And then next, our voltage sense. So it's also vitally important for the voltage sense to be installed correctly. As you'll see on top, we did say this is from right to left, 1, 2, 3. But underneath is from left to right, 1, 2, 3. So all of this wiring and diagrams are in all the user manuals. So if you have any doubts, please open that user manual and double check and make sure that's correct. And if we swapped 2 of these on the inverter, we need to swap both the voltage sense and the CTs around to make sure that is correct. So what happens if you put the voltage sense incorrectly? So if we put phase 3 here instead of phase 1, this CT is reading then. This CT here is reading the wrong readings. So it will essentially read the current out of step and it will see it as an opposite direction. So when you read that current out of step, it sees it as a reverse direction. Then normally the first instinct is the CT is on the wrong way, or the polarity on top is wrong. But it's never been the case. I've never found that ever. It's always the voltage sense needs to make. We double check that our correct voltage sense is on the correct CT. So when we install our smart meter, the smart meter can give us a lot of information. So on PV Master, it makes life easy for us. We can just open up, see which direction the power is flowing. But very often these are installed even with grid ties just to power limit that grid tie on its own. There we don't have any display or any meter data on any apps. We only have the smart meter to look at. But this is a good way to quickly have a look to see exactly what's going on. So the top power obviously needs to be on, so we know the smart meter is on and working. Next we have the blue energy flow. So if it is solid, it's consuming from the utility. If it is flashing, it's exporting. So if we know our inverter is not even on yet, we just powered up our smart meter and we see that it's flashing, then it's indicating that we are exporting. Then we can already know there's something wrong with our installation. We need to double check to make sure it is correct. And then lastly is the communication LED to see whether it's communicating with our inverter. So if it's blinking, it's transmitting data. In the reset, you will only see if the reset button is pressed, but normally we do not use the reset button. And it's always good to compare the energy flow on site with your multimeter. So if you have a clamp tester, look at PV Master, clamp test, switch on fixed loads so that you know more or less what the load will be drawing, and make sure that everything there is correct. Next is the smart meter test. So first, when we're on site, we're busy commissioning, we're doing the smart meter test. We've checked the smart meter, make sure that the power LED, the LED is flashing for communication, so it is communicating. Very often, our inverters are slightly further from the smart meter than the cable that is provided. Normally, in those instances, you can extend that cable. If you extend it, please don't use extender leads, one of those clip-in extender leads. Because it's RS485, the more parts you introduce, the more chances you have for interruptions. So if you do need to have a longer cable for the smart meter, replace the entire cable, remove the cover out of the inverter. Underneath we'll have those 4 screws. You pull that out, cut the old cable off, feed the new one in, crimp your head on, run your cable to the DB and crimp that end. And then you know you've got one solid cable that will work much better. Also, in the manual is the wiring output. So just a standard B termination is what we use for that RJ45s, but you can refer to the user manual if you have any doubts. So the inverters LEDs, so some of the inverters also show us different information regarding the smart meter communication that you can also have a look. So now we've made sure our smart meter is communicating correctly. We have to see, we run the smart meter test. I'll often get customers say, run it once, it gives me one answer, run it again, it gives me another answer. So we always need to make sure that each phase is drawing at least 150 watts from the utility. So if the PV is on, if we have batteries, we're covering all the loads, go and turn more loads on. Put as much load as you can on in the home so that the inverter can calculate accurately. If we do have any BMS communication errors or issues like that, if we don't have batteries, we need to make sure we set it to the no battery option so that the meter test will then ignore that BMS. So if the smart meter is not connected properly, it will also definitely fail. If there's any problems with that supplied BMS meter cable, sometimes because they are fixed, when we're running them nicely and trunking, sometimes they can get damaged, and then you might need to replace that. And lastly, which hardly ever happens, you might have a faulty smart meter when you can contact support to get a replacement. But it's very, very seldom that the smart meter is faulty. Normally, if they are faulty, they don't work at all. If they are on and they give readings and everything, normally there's no problem with the smart meter itself. It's normally a wiring issue that needs to be fixed. Now we have our next round of questions. So question number 1. The E2 inverter is stuck in fault mode due to an incorrect phase rotation. What is most likely the root cause? Question number 2. On the CT, the following is written K to L. To which side should the arrow point when installing? I hope I've said it enough times, but I'll give you guys the hint anyway. Number 3, where should the smart meter be installed? Number 4, with a 3-phase smart meter, how is the voltage sensed and the meters wired? So here we can see clearly, also in the user manual we have this. And number 5, where can you view faults that have occurred on your system with PV Master? Okay. Thank you very much, Nadine. Now in the poll, we continue. We do have a question. When we have no battery, can a smart meter test be done because the BMS communication has failed? So we do have an option for no battery in our battery selection. So if you select no battery option, then the smart meter test should work correctly because it should already pick up that there is no battery. If you don't have the option, it could just perhaps mean that the firmware of the inverter is a bit older and it doesn't have that option available. So now we move on to the on-grid errors. So again, the basic tools. Yeah, for the on-grids, a DC power supply is also a nice to have. Very often these inverters only power up from the DC supply. So if it is a problem on the modules or anything like that, it's nice to have a DC supply to test it. But we don't require you to have that. If the device is not coming on, we'll just send you a new one. So it's obviously always good to do preliminary checks for our devices just to make sure that our polarity and everything is correct. So one of our most common faults is isolation fault or ground eye fail. So this is where the insulation resistance between the ground and the panels are too low. So in a case like this is where the DC power supply does come in handy, because normally isolation fault or ground eye fail is a site-related query. If you have a DC power supply and if you power the device on with that, if you still have that, then that could indicate internal components have failed. So very often the PV modules can make a short circuit internally, or the insulation value is no longer correct. So that's why an insulation resistance tester is also good to use in this instance. You can check if the grounding is less than 10 ohm. If it's more than 10 ohm, then it's not. If it's more than 10 ohm, then the grounding is good. If it's less than, then it's not good. We can also see whether the error message disappears. So if you only connect one PV string at a time, you can also test multiple MPTs on the device and see whether that disappears. If it's on one specific string, then you can be certain of where that fault is. I said external DC power supply to start the inverter up to make sure that the inverter is not faulty. You can check if the neutral and AC wiring is properly connected on the AC terminals of the device. We check the voltage between neutral and ground to make sure that there is less than 10 volts. If the problem still occurs after completing the steps, contact us for support. This is a good example. So if you did go to the site, you did do this kind of testing, provide us this testing, and we would immediately say, we need to replace the device, we'll do the documentation and replace the device for you. Quickly, we have a question about the no battery option. If I choose the no battery option, is the smart meter crucial from start, or can I leave it disconnected? Well, it all depends on the operation. So it depends on what you need the device for. So if you need export power limiting, if you want to monitor the loads, any of those situations, then you should connect the smart meter. But if you are just using it as a pure grid tie just to produce energy, then it's not vital for that to be connected. But in order for you to monitor the loads, see the customer's consumption, you do need that smart meter installed. And I always say it's a good selling tool, because if you can show the customer his loads and what he's missing out on, it's easier to sell him batteries to show how much you can save. The ohm readings, I'll just double check. I unfortunately didn't create these slides on the hybrid expert, not so much the on-grid expert. I think we have maybe a bit of misinformation on this slide. I'll just double check that for you. Then next we have utility loss. Normally this is, especially in Africa and those places, when the utility goes offline. If we know the utility is on and we are experiencing utility loss or anything like that, we can check the circuit breaker, make sure that nothing has been tripped, disconnect the AC terminals, measure the voltage on the connector. Sometimes we have a loose connection or hot connection, it can also create problems. We can also make sure that the voltage is correct. Check the live, neutral, and earth on the inverter. Measure the impedance between live and neutral on the inverter itself. So if it's greater than 200 kilo ohms, then the inverter is no longer good. If it's less than 200 kilo ohms, if it's greater, then the inverter is good. If it's less, then there's a problem with the inverter, and you need to contact us. So then we have VAC failure. The grid voltage exceeds the protection safety of the safety code. So VAC failure is either our voltage is too low or too high for the safety code which we've set on the device. Normally you can change the country code to the device to 50 Hz default and see if that thing disappears. Just for testing purposes to see whether it is a problem with the voltage. We can check our AC cables, make sure they are properly connected. Sometimes a loose connection or hot connection can increase resistance on that cable, which means as soon as the inverter produces, the voltage will rise on the inverter, so you'll see a steady rise. And even if you set it to 50 Hz default, the voltage will rise past the safety of the inverter and it will go off again. Measure between neutral and earth to see if the voltage is less than 10 volts. If it's greater than 10 volts, then our grounding is poor. And if the AC voltage on the display is less than 253 volts, and you measure with the multimeter that is well below your country regulation, then the inverter might need to be calibrated or replaced. Then you can just contact us for that. FAC failure, very similar to VAC failure, except it's the frequency. Just make sure that our country's safety settings are set correctly. Sometimes this FAC and VAC failure, we might just need to update our inverter, recommission it, and then the problem will be resolved as well. But we always need to just double check and make sure the neutral and earth is correct and that all our cables are well connected. Next, with the on-grid inverters, I like to sit sometimes in waiting mode. And as I explained previously, waiting mode is waiting for a condition. If our PV is correct and there's sufficient PV power to supply the load, but it's still in waiting mode, then we just need to check a few things. So our XS series, STTG2 and SMT all have this nice connector in the blocks for the remote disconnect. We need to make sure that that is installed on the inverter, because internally there is a bridge piece which disables the remote disconnect function. So we just need to make sure that that is installed correctly and working correctly. Then for our empty series has a green terminal block on the connectors, which sits there on our main board in the connection area. That should be installed on the device. Sometimes you might find it in your accessory pack, not already pre-installed on the inverter. Just make sure that that is installed with the bridge piece in the correct position. Please note that the MT80 and MT60, it's different side ground. So the small inverters has it like this in the picture, but on the larger inverter, that terminal block is flipped upside down. So just double check pertaining to which side your screws are that this bridge is installed correctly. Then we got the monitoring devices. So first off is our Wi-Fi. So if you can't find solar Wi-Fi, you can see it, but you can't connect to it. You can connect to solar Wi-Fi, but you can't enter the 10.10.100.253 address to log into the Wi-Fi module. Or if the customer's network is no longer available and you're trying to connect to the device, there is the Wi-Fi reset button. So on the ES, you'll see there is an internal reset button, but on all the newer ES models, we have the new Wi-Fi module that has it on the Wi-Fi module itself. On lots of our other inverters, ET, BT, EMs, it is on the front screen. For our on-grids, if you have an LCD, you can reset it from within the LCD, or they should also all come now with the new modules that you can reset it on the module itself. Next, as I mentioned, that IP address at 10.10.100.253 is where we can log into the router to do that configuration, which is the configuration that I like the most. Because here we can see the RSSI in a numerical format. And that RSSI is the signal strength that we find with the customer's network. Normally, because of the location of the inverters, it's not in a general living area. Normally, the customers don't have sufficient range in those areas with their Wi-Fi. If we see it's less than 50 or 40%, we can know there might be issues with that. Then the customer might have to install a range extender or move his Wi-Fi access point closer. As I said previously, when you have a problem on site, if it's connected to the Wi-Fi, we can normally go and see what's happening. But if there's no Wi-Fi connection, and this is the problem the current customer is experiencing, we can always ask the user, please have a look at that Wi-Fi LED, what's it indicating, even if they make a short video that you can send to us for support. This will give us the first steps to look at what to troubleshoot when the device is not connected. So one flash we normally don't see, it's only when the system is resetting that we will see that. So when you press and hold the reset button, you'll see that single flashing. Next is double flash. So double flash is it's not connected to the customer's router. So when we have low signal or if the router is out of range, very often we can get this disconnected, but it's not connecting back to that customer's router because it is out of range. Or if the customer changes his network, then we'll also see that 2 flashes. Lastly, we have the 4 flashes. So 4 flashes means it's successfully connected to the customer's network. It cannot communicate with SEMS portal. So 4 flashes normally is the trickier one to fix. It's not related with our device. It's related with the Wi-Fi network and the Wi-Fi network security. Very often customers have firewalls and more secure access to their network, but all home routers have some sort of firewall to a varying degree. These 4 flashes can happen, especially on just a very simple home router. You might see it will work for a month and then it goes to 4 flashes. You restart the inverter, it works for a month, it goes to 4 flashes. That's normally a very bad firewall. Unfortunately, it only finds it once a month or scans the network once a month and then it finds this and blocks the communication. To ensure that it doesn't get blocked, the only way to do this is to open the TCP port 20001. 20001. It's the only port that needs to be opened for the inverter. This is often very bit more complex to do. Each router has its own way of doing it. Normally customers will just ask their ISPs, the service providers, to help them set this up on their router. If not, and you are a bit IT savvy, there's websites like portforward.com that can assist you to guide you on how to do that for every router there is. Sometimes if you get this off the bat, so immediately we get this 4 flashes when it connects to the customer's router, we can just double check that there's no unsupported characters in the SSID, so the Wi-Fi name or password. So there you'll see a list of all the supported characters, but if there's any other funny ASCII characters or blank spaces, that can cause this to happen as well. Next we have our loggers, like our FEC 1000 Easy Logger Pro. One of the most common faults that we get is it's connected, everything's working well connected, but our devices are now stuck in wait mode, they're not producing any PV, or there's no control to the device. Very often this is because we've not set the communication address on our inverters. So each inverter needs to have a different address. So if we have a big commercial site with 60 inverters, each inverter needs to be set to 1, 2, 3, 4, 5, 6, all the way up to 60. For our hybrid devices, we only have up to 10. So even though you're using a different COM port, always use a different number from 1 to 60 for the on-grid and 1 to 10 for the hybrids. If it's in any higher number, it may be out of logic range, and then there won't be control for that device. We also need to make sure that we are using proper twisted pair cables. For RS485, RS485 is very susceptible to outside interference. I've run an RS485 cable 10 centimeters, just use normal flat twin and earth or something like that, and the communication doesn't work. You need to use a shielded twisted pair cable, and you need to use a twisted pair. So internally, you always have these pairs of cables that are twisted together. So in the normal Cat6 cable or Cat5e cable, you'll find our colors So it will be a solid color and a striped color. Very sorry about it. So orange and orange white, for interest sake. So that is a twisted pair. So we'll have orange on A, orange white on B. You can use two twisted pairs if you have a longer run and you want to double up on the cables, but then you use orange and blue on A and orange white and blue white on B. And we use two twisted pairs. So it's very important that we use it in that manner to make sure that we are using those cables twisted to help to negate any external magnetic interference. Next, we have ProMate. So when we're configuring our device, we have the ProMate software. So our website is updated. It's slightly different now. I'm going to need to update this slide. You can go to our downloads section on our website. There you'll find under software, you'll find there's a whole long list of ProMate. Please always make sure if you're using EasyLogger Pro or SCC 1000 to use that SCC 1000 ProMate. We just have a quick question pop up about termination resistors. So termination resistances, especially if you're doing a commercial site and you have long cable runs, yes, it will be ideal to use that. Some of our devices like the MT does have a built-in termination resistance switch that you can switch on. The newer devices don't necessarily have that in, and installing a 120 ohm resistor at the last inverter in line is ideal. So as I was saying, the ProMate, you can just download the correct ProMate from our website. Currently the version is 1.1.0. And now if we made sure we have the correct ProMate for the device we used, we plug it into the device. We can upgrade the device as well. You can also get this from our support. Even before you go to site to commission the device, you can request them, create a support request, ask, can you provide us the latest firmware for my SCC 1000 or for my SCC 1000S? Make sure to give them the correct model name so they can provide you the correct firmware. That's put on a flash drive, simply plugged in, switched on, and it updates. Alternatively, we can update it later for you. So now we plug in our computer into the LAN, into our computer's side of the LAN. We need to make sure this device is in static IP mode. On the side of the logger, we'll see there is a reload button, a reset button. So here we can see the reset button. This reset button. We press and hold that for 10 seconds, as you see in this diagram. You hold it for roughly 10 seconds, then you need to see the LEDs. These blue LEDs will cycle from right to left. When they cycle from right to left, we know it's been set to static IP. If they go from left to right, it's been set to dynamic. So we set that to static. We press and hold that for about 10 seconds, let go, and we should see that sequence. If we don't see the sequence, we need to try it again, maybe hold it for a little bit longer, and let go of that button, and then we should see that LED sequence running. Lastly, then you need to make sure that our computer is set correctly, because you'll have to set a static IP address for the LAN of your computer as well. And that will just be your standard IPv protocols that you will set on this. So you can set 192.168.1 and then anything other than 200, and then the subnet mask, which is the standard subnet mask, and you don't require anything else. You can then just press OK, and then we should get successful communication. And then once we're done configuring this device in ProMate, you can set it back to DHCP. or you can manually press that reset button to reset it back to DHCP and then connect it to the customer's network. If you are only going to use DHCP, you can use that as well, especially if you only have a small network or a small dedicated router. You know, there's not a lot of devices. Then you can just plug it straight into a router. You'll automatically get an IP address that you can just type into ProMate and connect to it. Now we can have the last set of questions. Question number 1, for what is the DC power supply an effective tool? Question number 2, sorry. What is the cause of utility loss? Question number 3, what is the tool called to configure the EasyLogger Pro? Question number 4, what is not true about isolation faults? And question number 5, to set the EasyLogger Pro to a static IP, we have to press the reset button for how many seconds? Thank you very much, everyone. Everything will be sent out to you guys probably within a week's time of this presentation. So all the presentations material as well as the rest will be sent out to you within a week. And should you have not passed any of our previous courses, please note you can just retake that one specific module in order to pass, should you have not received enough marks on that specific module. But our team will notify you of this, that you can just redo that specific module. And the recordings will be sent as well with the presentation. Thank you for the feedback. We'll try and get better audio equipment for future presentations. If you're looking for our next training courses, you'll find them on our website under the GoodWe Plus section. There you'll see all our scheduled courses are available there. Well, thank you very much, everyone. If there's no further questions, then we can end the webinar here. Thank you very much for attending, everyone, and hope to see you in future trainings.